notice the different intro? Still the same coffee. Yeah, our school district decided that we couldn't go out on our own and do our own business, so I'm back to being Mr. Krause Math. So you will find these videos on NK Infinity, or you can find them in Mr. Krause Math. I'm going to update. I got a bunch of updating to do right now. I just don't have time. I'm going to do it this summer. So subscribe to the channel. That way you'll get updates. All of these will be in a Algebra 2 Common Core playlist. So if you subscribe to that playlist, boom, you'll be able to find them. Having said all that, if you're here just to copy me and watch Mr. Key work, let's see if I can write. I haven't done this in a while. Mr. Key, write. You are not in the right place. Go try the problems on your own first. Please go try them on your own first. Don't come here just to watch the trained monkey perform. I don't want to do that. I want to help you, but I want to make sure you know what's going on. Okay? So this is the Algebra 2 Common Core given on Wednesday, August 16th. It was like almost a full year ago. But I don't know why. I just got a little lazy, I think, this last year and decided not to make the video until now. But that's okay. I'm still hyped up to do it, so we're good. We're good. Let's see here. Let's move down. Let's just get started. Let's talk about this thing. You know what I haven't done? I haven't got my calculator open. Let's see if that's the calculator. I think that's the calculator. We'll start with that. So one of the things I want to do for you, I'm hoping to do for you, is to try to show you one or two or three different ways to solve these problems. Ooh, haven't had any coffee. Ooh, it's a little cool. I want to try to show you a couple of different ways to do these problems, okay? And if I can do that, and you can do this on your test, you're going to be in great, great, great shape. Don't give up hope. Keep working hard, all right? A fraction is only undefined when this thing down here in the denominators, 0. Because you are not allowed to divide by 0. So we don't actually care what the numerator is. Don't care. Go away. We don't like you. So this answer kind of doesn't make sense. They're trying to trick you with that one. So what we need to do is take this baby over here and factor it. So we get x squared plus 2x minus 8. And by the way, if you're that Hilton student that complains about my penmanship, coming after you. I'll try to work on it, though. I agree. It's something I definitely have to work on. Try to make my penmanship a little bit better just for you. X and X. How about we go with plus 4 and minus 2? So I get X equals negative 4 and X equals positive 2. There it is. Now don't circle the wrong answer. It's choice 1. I did say I was going to show you a couple of ways to do this problem, right? So I'm not sure, even if you have the older calculator, the TI-84, you can still do this. There's a stow button down here in the bottom left-hand corner. But what you'll do is you'll just take, what we're going to do is you're going to take these answers, and we'll start with these two since these are right anyway. And we're going to start with the number 2. And we're going to take 2, and we're going to store, we're going to take 2, and we're going to store it into X. And then you're going to type in the original problem. And I think it was x minus 3 over, man, got such a mess there. I can't even read my own writing. X squared plus 2x, so x squared plus 2x, and I think it was minus 8. Now look what happened. Shabam! Undefined! Whew! You mean it'll tell me when it's undefined? Yeah, because it equals 0. And we can do the same thing with negative 4. Don't just stop there. You got to try this one. Negative 4, control var x. Now don't retype that line in. Hit the up arrow until that thing's highlighted. Press enter, undefined again. As soon as you can graph it, or as soon as you can use your calculator, guarantee it's correct, hit the star button. Hit the star button. Draw a star on it. Put a C on it. Write yourself a note. Don't look at this again. It's 100% correct, okay? Never lose an opportunity to drink some coffee. All right. So that's one question that could be done using the star button. Here I go with the star button again, the calculator. But don't get in the habit of just using the calculator, because any one of these can be a part 2 question, and you got to be able to know how to do them. So we're going to do them the right way, the mathematical way. Like I tell my students all year long, I say put the calculator away, put the calculator away, put the calculator away. Because you got to learn how to do these things right. Now we're going to live within the rules of the Algebra 2 curriculum and the Algebra 2 Common Core test. So this says squared. Now these answers right here are designed for 9th graders that don't pay attention to detail, or that will like to do the easy way out. Oh, 3k squared, that's 9k squared. Oh, really? Great. Now we'll take this one and multiply it. Whatever. So that's trick 1. Don't fall for those goofy mistakes. Trick 2 is, you know, you're going to be dealing with I squared. And the one thing you got to remember when we drove this home, that I squared was equal to -1. And you know at some point that is going to come into play in this problem. So we're going to do 3k minus 2i. 3k minus 2i. Squared means write it twice. Bam! 9k squared. Well, that should come almost no surprise. They're both 9k squared. And then we're going to do this. Minus 6ik minus 6ik. So that's minus 12ki. Oh, gee, that should come as no surprise. They're both the same. But then we got this thing, and this is where you're going to earn your money right here. These two multiplied give me positive 4i squared. Because negative times negative is positive. But because we have this I squared that's really -1, that turns this thing into a -4. Therefore, this is your answer. What's that? You'd like to know if you can use the calculator just to solve this? Of course you can. I don't need you. Go away. So what we're going to do is, let me get a fresh screen. I like to say a fresh screen is like a fresh toilet bowl. You got to clean it out. You got to, if there's something in there, you got to flush it and get a clean one. You know what I'm saying? You know what I'm saying. You just think it's disgusting. I know. That's because I've had too much coffee already today. Some kid was complaining about the fact that I waste too much time drinking coffee. So what? So we're going to take any obnoxious number we can find. Don't use a normal number. Use an obnoxious number. Come on, I need K. And just press enter. Anything. And then the original problem, I believe, was 3K, let me look down, minus 2I. And you got to use the imaginary I down over here. You got to use this imaginary I. Not just the I down at this, that's down here somewhere. That doesn't make any sense. And we'll get out of that sucker. We'll get out of that sucker. Get out of that sucker. Boy, this thing's really not doing well. And we press enter. And look at that obnoxious number. Okay. But if we type in our answer, which is 9k squared minus 12. Now, this one you got to be careful with. Times k times I. Sometimes that causes problems. Oh, crap. Please don't freak out on me. And then, what did we say? It was minus 4, right? Shabam! Look at that, baby. The same answer. Are you kidding me? What's up with that? Start. It's done. Don't have to look at it again. Let's take a look at the next one. The roots of this are, I'm going to do this 3 separate ways. I'm going to try to factor it, not factorable, so probably not these two answers. So now I'm going to do it by completing the square, the quadratic formula, and the calculator. And I'm going to do the calculator one way. 2 ways. I'm going to do the calculator 2 ways. Sweet, Mr. Krause. That's awesome. 4 different ways to do this problem. You can do a problem 4 ways. You can circle it and say, I'm a genius at that problem. So, first things first, completing the square. Practice this. X squared plus 2x plus square equals -5 plus square. Now, I put squares there. They're really just placeholders. And remember, the first step is to move that 5 over. And when that 5 comes over, it becomes negatory, sir. All right, here we go. X plus whatever the sign is, whoosh, that comes down there. And then whatever half of this is, 1. That's just how it works. That's how completing the square works, 1. And we're going to take 1 and we're going to square it and put it there. And we're going to put it there. So -5 plus 1 is, in fact, -4. So now what I'm going to do is I'm going to take my big, dark, great pen there and do a plus or minus. Now remember, when you take the square root, you got to put a plus or minus. And that's the way to get rid of this square. I always get these kids that say, oh, should I double distribute that out? Oh, yeah, double distribute it. Guess what you get? You get that. Don't do that. So I end up with x plus 1 equals plus or minus 2i. Slide the 1 over, and I get x equals -1 plus or minus 2i. Now, that's by completing the square. That's this. Here's the answer right here. That's one method to do it. Let's do method number 2. I know you're excited about this. You'll think, you know what, Mr. Krause? I think we should do every problem 4 ways because I love math that much. No, actually, the reason I do it this way is because maybe one of them just hits best with you. Maybe one of them is your favorite and you just want to do it that way. Maybe the quadratic formula is your favorite. Now, the quadratic formula is written like this. X equals negative b plus or minus the b squared minus 4ac all over 2a. Now, that is on your formula sheet. You don't have to have that memorized. But I hate this formula. I hate this general way of doing it. What I like to do, and I did this a long time ago, I split this up. I put this over 2a, and I put this over 2a. And I'll tell you why. Look at the way the answer is given. It's not over one fraction. It's each piece separated. And that's why we do it. So I always do a equals, b equals, c equals, and finally d. D is the heavy work. D is the heavy work. That's this stuff right there. Right there. Right there thing. So a is 1. It's the number right here. B is 2. It's the number right there. C is 5. It's the number right there. And D, which is b squared minus 4ac, is b squared is 4 minus 4. That is not a 4. Every time I draw a 4, it's problematic. 4 times 1 times 5. Now, I'm not going to waste your time and put that in my calculator. I know that's negative 16. I just do. That's how good I am. So I'm ready to go. X equals negative b is negative 2 over 2 times 1, but that's just 2. Plus or minus, I remember I'm plugging back into this formula right here. The square root of negative 16 over 2. Now, you should know that the square root of negative 16 is not negative. It is 4i. All right, so I get x equals negative 1 plus or minus 2i. Same answer as I got before. But Mr. Krause, I don't like that way. I want to do it just using the calculator. Okay, there's a few ways to do it. Now, let's say you forget a few things. Let's say your calculator is not as nice as the one I have. Let's say you just want to graph this thing and you want to see what the answers are what it'll be like. So just go into graph mode, and you're going to type in x squared plus 2x plus 5. And you graph that. Well, you notice that it's up here. You notice that it's sitting up here. That's because it never hits the x-axis, or because it never hits the x-axis. That means there's no real solutions. So at a very minimum, you could say, okay, I know those can't be the right answer. I wonder which one. And if at this point you want to, just guess. You could just guess. All right, so here's 2 ways to do this problem. 100%. If you have this calculator, great way to do this problem. The first one is we're going to take the answer. Negative 1 plus 2i, and then we're going to do control var x and press enter, and then we're going to type it in x squared plus 2x plus 5. Shabam, you get 0. There's your root. Done. Done. Now, for those of you that also have this calculator also factors for you. Yours is, if you've got this one, it's menu, poly tools, and then find the roots of a polynomial. If you don't have the CAS version, it's just menu 331. You're not allowed to use the CAS version on the Regents exam, but the old version, the other version has this as well, solve the poly tools. Now, if I was to solve this using real functions, and I did this, 1, 2, 5, you'd see that it says the answer is the empty set. That's because the answers are imaginary. So if I do that again, menu, algebra, poly tools, and find the poly's, but I can also change to do complex and do the same thing. 1, 2, and 5. And there we go. 1 plus and minus 2i. Man, I did that problem 4 different ways. Start it. First 3 questions. All can be done using the calculator. Oops. This problem right here can be done just using the calculator. But oh my gosh, this is a hard problem. However, since this problem could easily be a part 2, probably more of a part 3 question, because this problem is bad. As a multiple choice, it's easy, but as a extended response question, this would be tough. So I'm going to show you how to do that in just a second. You guys ready? Let's do this. Thank you, Dunkin' Donuts, for the sponsoring. Not. The only thing you're sponsoring is my heart attack later on coming on. All right. If you're going to solve one of these crazy difficult questions, I call them crazy difficult until you get into pre-calc, and then they're not too bad. But they're crazy kind of difficult questions. What you have to remember to do is to isolate the weird thing. That's what I say all the time. Isolate the weird thing. Get the weird thing alone. Get the weird thing alone. However, in this particular case, you can't do it. Because there's two weird things. So we got to isolate one weird thing at a time. Now, since this thing is a negatory, we're going to move it over. So we're going to get the square root of x plus 14 equals 1 plus the square root of 2x plus 5. Now, the trick to getting rid of a weird thing, which in this case is a radical, is to do its inverse operation. In this case, the inverse operation of a square root is a squared. Now, since I'm going to square this, I might as well just write it twice right here. I'm going to be on this problem for about 6 months, so just pay attention and bear with me. Left side's easy. That's just x plus 14. The square and the square root, bam! Cancel each other out, just like that. All right. 1 times 1 is 1, plus, this is one of these things, and this is one of these things. So that's the square root of 2x plus 5. Plus the square root of 2x plus 5. Now, if you were smart enough and just put a 2 in front of that, that's fine. You can do that too. And then the square root of 2x plus 5 times the square root of 2x plus 5 is just 2x plus 5. All right, let me clean this sucker up. We got x plus 14 equals, I'm going to leave this up front, 2 square roots of 2x plus 5. So in other words, I combine these suckers, plus 2x plus 6. Now the 6 comes from that 1 and that 5 being added together. All right, now we got to isolate the weird thing. And this time my weird thing is this. That's my weird thing. I'm going to isolate that sucker. So I'm going to move this 2x over. I'm going to show you because sometimes it's complicated. I'm going to move this 6 over. So I get negative x plus 8 equals 2 times the square root of 2x plus 5. At this time, if I wanted to, I could divide by 2, but that would cause all kinds of problems on the left side. So you know what I'm going to do? I'm going to go on faith that you guys are pretty smart kids. I'm going to square this side, and I'm going to square this side. So this would be, oh, got to double distribute this one. Negative x plus 8. So this gives me x squared minus 8x, and minus 8x is minus 16x plus 64 equals, that's set to 4. 2 squared is 4 times 2x plus 5. Right, because I squared this and I squared this. All right, so what do we got here? We got x squared minus 16x plus 64 equals 8x plus 20. Anybody, you guys still with me? I hope so. I hope so. Let's bring everything to the left side. We got x squared minus 24x, that's a 24, plus 44 equals 0. I factor this sucker, and I get x minus 2, x minus 22. Again, if you're stink at factoring, if you're like, I am the worst, by now you should be amazing at factoring. So, you know, if you're not, come over here, go menu, algebra, polytool. So in your calculator, probably menu 331. Click on this, 1, negative 24, that's a negatory 24, and 44, click OK, boom, there's your two answers, 2 and 22. So what most kids would do is go, I got it, oh. But I know doggone well your teacher, if they're any good, said you must check your answers. You have to check radical questions, log questions. Lots of questions need to be checked. Radicals and logs absolutely have to be checked. So my answers are not x equals 2 or x equals 2 and x equals 22. Maybe they are, maybe they aren't. So then you're saying to yourself, if I just had to check the answers anyway, why didn't I just start by checking the answers? Exactly. You should have. So the first one I'm going to check is 2. Because if 2 works, then it's one of these two. If 2 doesn't work, then 2 and 4 have to go. So I'm going to do that first. 2. Control var X, press enter. Oops, shut up. Bam. The square root of x plus 14 minus the square root of 2x plus 5. Now, I don't use the equal sign because it's problematic. You have problems when you use the equal sign. So try not to use that. It's a bad one. It equals 1. And we want it to equal 1. So 2 works. That means these two are out completely. I now have to check 22. So 22, control var x. Remember how I said this problem's easy if you just do it using the calculator? It is, right? And you get -1. So 22 did not work, so this is your answer right here. So that's a really easy question just using the calculator, but not so much any other way. So start again. That's 4 in a row that I could have straight up used the calculator for and got the answer. All right. Let's talk about this tangent function. So one of the things you should have learned, and I'm going to show you how to use the graphing calculator as a tool for this, but one of the things you should have learned is the graph of the tangent curve. The graph of the tangent curve has 2 lines that are asymptotes. The first line that's an asymptote is down here at -pi/2, or 90 degrees, -90 degrees. The other asymptote is at +pi/2, or 90 degrees. Now, this 2 actually has nothing to do with anything in this problem. It is just a dilation of 2, which just means that this tangent curve is getting steeper faster, a little bit, not much. So if you remember correctly, the tangent curve looks like this, like that. So the question says is, from 0 to pi/2, what is this thing doing? Well, this is 0, and this is pi/2. So as I go towards pi/2, what is happening? It's increasing without limit. Now, can I do that on the graphic calculator? You bet you're a skippy. Hope I remember how to do this. I'm terrible at this stuff. All right, I'm just kidding. See how I got 1, 2, 3, 4, all these tabs open? Get rid of them, close them up. Always start with a fresh toilet. I mean a fresh screen. You know what I mean. Jelly bean. What the hell am I on me? Tangent. Oh, forgot the 2. Escape. 2 times tangent, shabam, of x. Bam. Enter. Now that's crazy looking, right? Who knows what that looks like? I don't want that. But the problem said to go from 0 to pi/2. So I'm going to change this to 0. And I'm going to press tab. I don't care about that one. I'm going to press tab. I'm down here on the right. You see me down here on the right? I'm down here on the right. Now I want to change this to pi/2. So I'm going to go shabam pi divided by 2. Press enter. Now that's kind of hard to look at, so maybe I should have made this, like 30. I don't know, maybe make it bigger. Oh, look what's happening. It's going from 0 to pi/2. It's going up without bounds. Do you see that? Maybe I need to move my big head. Can you see it? Maybe I need to move this. I think before one of my old videos I did this. Did I just swear? I think I just swore. I always make these stupid sound effects. I don't know why. So I'll put this over here like this, get it out of my head's way. But you'll see it's growing without bounds. So that's the calculator way to do it. All right. Holy mackerel, that's only 5 questions. We're going to be on this all day. All right. I'm going to show you the focus directrix way to solve an equation. And I'm going to show you how you can use your calculator on this one as well. Okay? So let's take a look at this. The way I teach focus directrix might be a little bit different than the way your teacher teaches it. I teach it, just come up with an arbitrary point. Now you should know what the general look of a focus directrix question is. You have a point called the focus. You have a directrix, which is a line, and somewhere in the middle is the vertex. And your parabola should go like this. Now it could look like this, or your focus could be down here, and this could be your focus, and this could be your vertex, and it would look like this. Now, this means we have a leading coefficient that's negative. That means our x squared term is somehow negative. This means our x squared term is somehow positive. I wonder if I can simplify this. Maybe what I can do over here real quick is to get a quick picture of what's going on here. Let me see if I can just get a quick picture. We got a focus of 0, negative 1. And we got a directrix of y equals 1. Now the vertex is right in the middle. It's got to be right here. And this means it's going down. You go away from the directrix. Okay. That means it has to have a negative leading coefficient. That means these two are out. Now at least I'm down to a 50-50 guess. Remember, this one here is y equals negative 1/8 x squared. And this one is y equals negative 1/4 x squared. I assume you realize I divided by negative 8 divided by negative 4. So these two are the negative ones. One of those two is, in fact, the correct answer. All right, and I told you I am going to show you an easy way to do this on the calculator, but I do want to walk you through this. So we pick any arbitrary point called xy, and we find two distances. Distance 1 is the distance between y and the directrix, just y minus 1. And then the distance between these two, and we use the distance formula. X minus 0 squared plus y minus negative 1, but y minus negative 1 is really y plus 1 squared. Now what I do is I set these two distances equal to each other. In other words, y minus 1 is equal to x squared plus y plus 1 squared. Now what I got to do is, in order to get rid of this square root over here, I got to square this side. And I got to square this side. Now remember, squaring this side means you're going to write this twice and double distribute it. I'm going to skip that step, so I assume you can write that twice. You get y squared minus 2y plus 1 equals x squared. Now I still got to double distribute this, plus y squared plus 2y minus, plus 1. Now let's see what happens. This y squared cancels with this y squared. This 1 cancels with this 1. And this minus 2y I got to bring over. So I get minus 4y equals x squared. Oh, that's this. There it is. Got it. There's the answer. Now, how can I use the graphing calculator for this? You're not going to like this if you don't have this calculator. Don't shoot the messenger. Just know it. All right. I said it was that one. So it's negative 1 control division over 4 x squared. Enter. There it is. So, menu, analyze, and we're going to find the focus. And if you click on the graph, it will tell you the focus is 0, negative 1. And in fact, the answer did say 0, negative 1, or the problem did say that. Analyze, directrix, click on the graph. There's the directrix of y equals 1. And you could just do that. Solve each of those answers, solve each of these for y, and then graph them and use your calculator if you want. All right, this problem here. This problem's a little funky-dunky-bunky-dunky-dunky. So it says, which diagram represents an angle alpha that is 3 pi over 20 and has a reference angle of theta? Okay, so I think you should be able to eliminate a couple of choices. First of all, theta, the reference angle, a reference angle is only made with the x-axis, not with the y-axis. And it has to be the closest x-axis. A reference angle is an angle made with closest x-axis, which in other means it has to be less than 90 degrees. All right? All thetas have to be less than 300, but it has to be made with the x-axis. This one, made with the y-axis. This one, notice this angle right here, bigger than 90 degrees. This one has a reference angle, that's good. And this one has a reference angle, that's good. Okay, now we're in good shape. Now, we got to talk about which one's the right one. First and foremost, it said 12 pi over, did it say 12 pi? 13 pi. 13 pi over 20. That's positive. Positive angles go in this direction. Now, from here to here is pi. You know that. This is a little bit more than half of pi. So a little bit more than half of pi would be just about here. That's this angle. That means this is the reference angle. Choice 4 is the right answer. How'd you do? Did you get it right? I hope you're doing well. Well, what do we have here, kids? If you were to graph this thing, I'm going to show you a couple different ways, but if we were to graph this thing, and you were to use your graphing calculator, red X, choose, don't save. By the way, you got to use X's, you can't use M's, but if you were to use X squared, minus 4, and in parentheses, X squared, was it plus 1? Plus 1. You'll see that you only get two answers. You only get two answers. You get answers at -2 and +2. So -2 and +2 definitely work. There is no -4, so this answer is just stupid, and this answer is just stupid. Because it's at positive and -2. So we know it's got to be one of those two answers. And I think most of you realize that if you factor this thing right here, and you factor that, you get m plus 2, m minus 2. But, and then that would give me these two answers. But what am I going to do with this thing? This m squared plus 1. Does that give me answers as well? I believe it does. And what you're going to do is you're going to set that equal to 0. M squared plus 1 equals 0. Now, I could have done the same thing with this one too, right? I could have done the same thing with this. M squared minus 4, set this equal to 0. M squared minus 4 equals 0. M squared equals 4. Take the square root, and don't forget, when you take a square root, you put a plus or minus. That's where the plus and minus 2 come from. I'm going to do the same thing. I'm going to subtract 1. Subtract 1. I get m squared equals -1. I take the square root, and I got to remember to put a plus or a minus. Plus or minus -1, that's plus or minus I. So this actually is the right answer. Now, having said that, I believe you could have used your calculator but to solve this as well. But the first thing you would have had to do is double distribute this. M to the 4th plus m squared minus 4m squared minus 4. If you double distribute all this out, you get that. Well, this is just minus 3m squared. Now, how can I use my calculator for that? Oh, okay. Red X, go away, see you. And I'll go menu, algebra, polytools, find the roots. Now, did you notice we had some possible complex answers? So we'll choose complex. We'll click OK. Oops, cancel. It is a 4th degree polynomial complex. So the first term is 1. Is there a cubed term? Nope, 0. Is there a squared term? Yep, -3. Is there a single linear term? Plain old m? Nope, 0. And at the end we got -4. There you go, plus minus 2i, plus or minus I. All right, here we go. Oh, this problem, woo! This problem was cray-cray. So this is crazy. What's going on? Stop. This is an average rate of change question. Or in my class, it's an AROC. An average rate of change question. So y is subtracted on top, x is subtracted on bottom. X's are easy. We'll get to those in a second. But we're going to subtract the x's on the bottom, subtract the y's on top. But here's the problem, and this is crazy. This is a good question. I like this question. So whoever wrote it was a good question. Log base 8. It's actually not that hard. It just looks funky-do, funky-donky. V over 1700 or 17,000 equals t. The problem with it is they're giving you t. and you got to solve for v. So in other words, the first thing you're going to have to do is take this sucker and solve for v. Now, I know you all work with me on my logarithm unit, and you know it's all about that base, about that base, about that base, all about that base. Okay, if you don't know anything, look up my All About That Base video with me and Miss Nooms. You'll know what I'm talking about. The base of this function is 0.8. This is a log function. In order to solve a log function, you have to use exponents. You have to change it to an exponential function. So my base is 0.8. Logs are equal to exponents. This is my new exponent. So 0.8 to the t is equal to, well, I've used this and I've used this. Now I used the log because I turned it into an exponential. It's equal to v over 17,000. In other words, v is equal to, when I cross multiply or multiply this side by 17,000 and multiply this side by 17,000, v is equal to 17,000 times 0.8t. All right, that's the first bad thing you had to do. The second thing you had to do was figure out what the numbers are. Now, 2011 is when we bought the car. So 2012 would be 1 year later. 2014 would be 3 years later. So I got to come over to my calculator, and I go 17,000, parenthesis, 0.8 raised to the 1. So 13,600. So at t equals 1, we got 13,600. And at t equals 3, we have 8704. So what is the average rate of change? Okay, we'll take 13,600. We're going to subtract off 8704, and we're going to divide that by 1 minus 3. All right. Control division. This minus this all over 1 minus 3. Shabam! 2448. And to the nearest $10, there she is. That's the average rate of change. Now, it's negative because it's coming down. It's a negative rate of change. They already said it was a decreasing rate of change. That's why we ended up with negative, but the change is 2450. Crazy question. That was a tough one. Alrighty, we are almost done with this. We've got some iridium. 192. Oh, that sounds so complicated. Okay, it's a half-life question. And my phone's blowing up and I don't know why. Oh, well, we'll figure that out. So, iridium 192 is an isotope of an iridium and has a half-life. Okay, it's a half-life question. Hopefully those of you that learned half-life question, we got a half-life, and that is that thing right there. Now, all of this problem is really just a test and see if you know something about exponents. That's it. Believe it or not, this is an exponent question. This guy, whoever wrote this problem, decided they wanted to write a problem about exponents to see if you know anything about exponents, but we're going to disguise it in a half-life question. So here's the thing. This right here is my exponent, correct? I can rewrite that as 1 over 73.83. I'm going to show you another way to do this problem, I believe, times t. Okay. So, in other words, this, by the way, the exponent on this is 1. What do we do with exponents raised to exponents? We multiply them. So this is really 100, 1/2 to the 1 over 73.83 to the t. And this right here is all you got to do is put that thing in your calculator. I don't know why I'm in that. Let's go to this. Shabam. Let's get a fresh screen. So 1/2, I'm just going to do 0.5, it's easier, raised to the control division 1 over, oh my goodness, 7383, it's right there, 73.83. Shabam, there it is, 0.9900658. There it is. It's this answer. Right? It's this number right here. Now let's see if there's a way we can get our graphing calculator tool to help us out with that. I wonder if there is. I actually haven't tested this, but I'm thinking there might be. So let's try this. We've got 100 raised to the 0.5 raised to the, and then this is a fraction, x, you got to use x, over 73.83. Now, you're not going to see anything, so you got to be smart enough to realize you're not going to see anything. This is an exponential decay question, tab. This is an exponential decay question, right? That's got a start value of 100. So if you want to see this, you got to change this value over here up to like 150. Oops. Well, we don't care about this. So let's see, leave this as 0. And we'll change this to like 150. And we'll change this to like 50. All right, there it is coming down. So that's what it looks like. Terrible question. Let's try and make this 500. That looks more like a decay question. So you could play around with the screen. Well, if you could do that, then you've learned something. You know a little bit about half-life questions. Now let's test ours. Tab 100, parenthesis, 0.99056, I think was 050656. 0656 raised to the x. Now, if we got it right, it should be almost exact. It's another way to do the problem. It should be another way to do the problem. All right, there it is. 2 ways. 2 left, kids. 2 left, and we're done. Oh, this one's easy. So, here we go. The distribution of diameter of ball bearings is made under, and it's normally distributed with a mean of, as soon as you see normally distributed, you should draw the normal distribution curve. Hopefully this is not in my head, behind my head. Or I didn't draw, just draw a hat on myself. With a mean of 4 and a standard deviation of 0.2. And they're asking about 3.7 or less. Well, you know it's got to be less than half. So none of these 2 answers don't make sense. This is down here at 6%, so that answer doesn't make sense. Oh, wait, hold on. That answer, one of these 2 answers makes sense. Oh, look, 0.2. So this is really far away, but let's check this out. What we're going to do is we're going to go back over our calculators, and we're going to use the normal CDF feature of our calculator. You have this on the TI-84 too. Just look for normal CDF. So in this calculator, it's menu 652, I believe. The lower bound is negative infinity. You should have something like negative 9,999,999, whatever you want in there. Upper bound is 3.7. The mean is 4. And my standard deviation is 0.2. And you get 0.0068, and there it is. Done. Can't get any easier than that question. Man. Simple. However, that question went into this question, and then we got a little cray-cray. All right, we got us a little cray-cray. So, it says that these are the x-intercepts of this polynomial p of x. Now, this used to model the volume of a rectangular pyramid. Who cares? These are our x-intercepts. Now, we know our x-intercepts, if we have an x-intercept of -2, that came from a factor of x plus 2. An x equals 10 came from a factor of x minus 10. And a factor of x equals 14 came from x minus 14. So this choice A doesn't make any sense whatsoever. Choice P looks like, choice B definitely works because those are the roots. And whether or not I put a negative out front or not, those still would be my x-intercepts. Whether I put that negative out front or not, they're still my x-intercepts. So that one works. So anything with a B in it works. So it's got to be down to C or D. It says the maximum volume occurs at x equals 10, or the maximum value of the box is approximately 56. So we're going to have to use our graphing tool to do this one. Now, since we just figured out this was P of X, now we have our tool. So let's do this. Go into graphing mode. And we're going to do negative x plus 10. Oops. Plus 2, right? Negative x plus 2. Parentheses x minus 10. Parentheses x minus 14. Bam. There it is. Whoa! What the heck is that? So you can't see it well. Let's see. Double click on that. We'll click on this. I don't know. Make it 30. Make it 100. Make this 30. Make this negative 100. I don't know. I mean, stretch it out a little bit. See what we got. Oh, there we go. Now we can get a good picture of this. We really should be able to see the minimum, but it didn't ask about the minimum. It asked about the maximum. And right here is our relative maximum. As a matter of fact, that's probably our absolute maximum, because since it's a real-life question, anything over here doesn't matter. It has to start at 0. X has to start at 0, only because it's a real-life contextual question. So we got to find that max. Menu, analyze graph, maximum, shabam, shabam. The maximum occurs at 12.1, so at X equals 12.1, that's our max. So that appears not to be the correct answer here. And our Y value is 56.3, which is approximately 56. So B and D work. Woo! All right, kids, that's it. That's all she wrote. That's part 1. Oh my gosh, that took forever. Hopefully you learned something. I did problems like 4 different ways. It's anytime you can do something graphically, algebraically, and on there, and you know, using your calculator as a tool, you're in great shape. All right. Those weren't too bad. Hopefully I'll have a link on this video that'll go to the next video. If it doesn't, just keep looking. I'm sure it's there. Or you can go to Mr. Krause Math or NK Infinity and search for New York State Regents Exams. Okay? All right, kids. Goodbye. Thanks for subscribing, by the way. Thank you very much. I appreciate it. I do. I really do.